Our next project is the table robot. This robot is another application of IR sensor. This robot freely moves on the table without falling from its edges. We'll be using the following components to make this robot: one IR pair module, one 10K resistor, two DC motors, two wheels. Now let us see the flowchart for the table robot. In this, we'll be having the input as 5V voltage supply, an IR sensor to sense the edges of the table, and a table which will be our arena. The most important thing that has to be kept in mind while making this robot is the left motor is directly connected to the common pins of the relay, whereas the right motor is connected in the same polarity to the NO pins of the relay. In this robot, we'll be having a cross connection between the NO and the NC pins. In this robot, we'll be having two conditions. The first condition is when the IR senses the table, and the second condition is when the robot is at the edge of the table and the IR doesn't sense the table. In the first case, when the IR senses the table, the transistor will be forward biased and the relay will be triggered, which in turn will make the motor run in the forward direction. In the second case, when the robot comes to the edge, the IR will stop sensing the surface of the table, which will stop biasing the transistor, and the relay will be stopped triggering, which in turn will stop the motor and the robot will take a right turn. Now let us have an understanding of the IR module. Infrared technology addresses a wide variety of wireless applications. The main areas are sensing and remote controls. In the electromagnetic spectrum, the infrared portion is divided into three regions: near infrared region, mid infrared region, and far infrared region. The wavelengths of these regions and their applications are as follows. Near infrared region, the wavelength is from 700 nanometers to 1400 nanometers, and its applications are IR sensors and optical fibers. Mid-infrared regions, the wavelength is from 1400 nanometer to 3000 nanometer. The application is basically heat sensing. Far infrared region, the wavelength is from 3000 nanometer to 1 millimeter. The main application is thermal imaging. The frequency range of infrared is higher than microwave and lesser than visible light. For optical sensing and optical communication, photo-optics technology are used in the near infrared region, as the light is less complex than RF when implemented as a source of signal. Optical wireless communication is done with infrared data transmission for short-range application. An infrared sensor emits or detects infrared radiation to sense its surrounding.